Alright, let's take a look at question number 6 on your take-home. We've got this piecewise function here, which is over here the graph of g, and we are going to see that f of x is defined by the graph minus this cosine of x divided by 2. And so they're going to ask us three little questions, two questions about this, A and B, and then C is just relating to the graph only. So this is a good question where I would say that if you read it and you kind of freak out, that maybe this time you start off with part C, because part C just says find the derivative of h, where h is defined as the integral of 3x of gt dt, and they want you to find the derivative. And in this particular problem, on part C only, this is the second fundamental theorem of calculus, right? If you're finding the derivative, and it's defined by the integral, so if you take the derivative of the left side and the derivative of the right side, hopefully that will clue you into the fact that since you're taking the derivative of the integral, that we're just going to replace the variable t with that 3x. So you have g of 3x, but it's not just regular x, so you have to take the derivative of that. So this is the derivative of h of x. And then they want us to evaluate h at negative pi over 3. So we just plug in g 3 times negative pi over 3 times the 3. So inside the this portion you have the 3's canceling out, and you just want to find the graph value at g of negative pi, and then we're going to multiply that by 3, and that's going to give me the derivative value at negative pi divided by 3. So just go to the graph at negative pi, you're right here, and you just go up the graph, and you see that the y value is a positive pi. So part C, h prime at negative pi over 3 is equal to 3 times pi. It's 3 pi. Okay, so it turns out that in this problem, in my opinion, part C is certainly in our grasp here. A and B might be a little tougher, but if we have time, we can probably muster through this. So let's take a look at A. So we're kind of working out of order here, but sometimes that's a good strategy to have on a test. And then maybe part A will make a little more sense. So part A, we're taking f of x, which is defined here, and we are going to take the integral from negative 2 pi over to 4 pi, which is what this graph is defined for here. And we notice that we can expand this out, and we can say that the integral of f of x from negative 2 pi to 4 pi is simply equal to the integral of same range of g of x, which is the graph, minus the integral from negative 2 pi to 4 pi of the integral cosine x over 2. So let's talk about the first part. This first part is simply the integral of this graph g of x here, and the integral of that is just the area under the curve. So we're either going to use Riemann sums, or we can use, in this case, we can just use geometry, and notice that this triangle has a base of 6 pi units, right? And it has a height of 2 pi. And so we're just going to use the geometry formula. Area equals base times height divided by 2. So we have 6 pi times 2 pi divided by 2. That would be 12 pi squared divided by 2, or 6 pi squared. So that's going to be the area underneath my curve. And now we can actually take the integral of cosine x over 2. So in this case, well, this is not just cosine of x, it's cosine of x divided by 2. So we need the derivative of x divided by 2, which is 1/2, sitting right in there next to the function. And in order for me to add this 1/2, I need to put a 2 out in front of that, right? So this is negative 2 pi to 4 pi of that integral. So what is the integral of cosine? It's positive sign, right? So we have minus 2, and the reason it's minus is because this function is being subtracted, right? Minus 2 sine of x over 2, evaluated from negative 2 pi all the way up to 4 pi. And we already know that our area is 6 pi squared from the area under the curve. And finishing this up, I'd like to make a note here that the unit circle, if I travel in the counterclockwise directions, that is, or excuse me, the clockwise direction, that is negative pi. And when I go there, it's a negative 2 pi. So negative 2 pi starts at the origin. So that's the same thing as taking, anyway, so let's take a look at the going around the other direction. Well, the other direction, which is what we're used to going, you make a trip there, you're at pi, you're at 2 pi, make another complete trip, and you are back there. So 4 pi and a negative 2 pi both take you back to this place here on the graph. So, well, let's just plug in the values just to reassure us that that's the case. So we still have 6 pi squared minus 2 sine of 4 pi over 2 minus 2 times the sine of a negative 2 pi over 2. And of course, this turns out to be 4 divided by 2, so it's sine of 2 pi. And 2 over 2 would be a negative pi. So what is the sine at 2 pi? Sine is all about the y, so if I'm at 2 pi, I don't have any height at all. So this just turns out to be 2 times 0 minus, still have my 6 pi squared. At negative pi, I still don't have any height because I'm right here. So that's minus 2 times 0. So the final answer for A is just 6 pi squared. And I forgot to put something important here. I should have my dx here and my dx all the way through here. So just something you can think about while you're checking your answers on these free responses. Let's take a look at B. This is a little bit tricky here, B. Hopefully this will make a little bit of sense. They want us to find the critical values of this graph, right? And not this graph, but in particular f of x, right? Which is the piecewise graph, or this triangle minus cosine of x over 2. So we know that in order to find the part B, to find the critical values, we have to take the derivative of f of x. So that's simply the derivative of the graph, which is just the slope of the graph, and then the derivative of cosine of x over 2 is negative. So we have minus a minus sine of x over 2, and it's not just x, it's a half an x. So the derivative of x divided by 2 is just 1/2. So cleaning this up so that this will make a little bit of sense, we have g prime of x plus 1/2 of sine of x over 2. And we have to make some sort of sense of this. So let's go back to the graph. We see here that the derivative of this graph is just the slope of that line. Well, on this interval, it is a positive, goes up 2 pi and over 2 pi, so it's just a slope of 1. And that's on the interval from negative 2 pi up to 0. And then notice what happens. We have a sharp corner, right? So we know we can't take the derivative. The derivative does not exist. This is g prime, right? G prime does not exist, d and e, at x equals 0. Right? It's continuous there, but you can't take the derivative of that sharp corner. And then when I turn and go down this triangle, this slope is what? Looks like a negative. See, I'm going down 2 and over 4. So down 2 over 4. And the slope of that one is just simply a negative 1/2. Alright, let's see if we can write that as a piecewise function. So f prime of x is equal to, so it's positive 1 here when I'm on the left, and plus the cosine portion, which would be 1/2 sine of x over 2, and that exists from negative 2 pi ran out of room here. Let me rewrite this real quick. Make this a little bit smaller for you. So this will be 1 plus 1/2 sine of x over 2. And that exists from negative 2 pi x and up to 0. Now notice that I did not put the equal to sign here because this graph simply starts at negative 2 pi. I don't know what's happening just to the left of that. I just know that that negative 2 pi exists there. And of course at 0 it doesn't exist because, not because of the continuity, but because of the fact that this is the derivative, and the derivative does not exist there, as we already discussed. So let's take a look at the second half. When I turn the corner, the slope is, what I say, negative 1/2. So negative 1/2 plus 1/2 sine of x over 2. And that exists from 0 to 4 pi. And same thing. We can't say equal to because the sharp corner, and also because of the fact when I get to the end, I don't know what's happening immediately to the right of that. So we're going to cut it off at 4 pi. Well, what is a critical value? Critical value is where the first derivative is equal to 0, or the first derivative does not exist. So we have a cusp or a sharp corner right there, so we know it can't exist at 0. But let's see if we can take a look at just the first half of this graph, this portion right here. So if I take that derivative and set it equal to 0, we have 1 plus 1/2 sine of x over 2. Set it equal to 0, we would subtract 1. And then we have the quantity 1/2 sine of x over 2. If I multiply this by the reciprocal 2, we have let's see, that cancels, and we have sine of x over 2 is equal to a negative 2. Now here's where it helps just to know a little bit about the graph of sine and cosine. If I have the graph of sine and cosine, it starts off at 0, and I'm not too concerned about the frequency of this or the period of this, but I do know that it has an amplitude of 1. So it's going to get as high as positive 1 and as low as a negative 1. So will it ever hit negative 2? And the answer is no. It will not hit negative 2. So we don't really have any critical values. And actually that's going back in this direction, right? Back in that direction, well, forever it'll never hit negative 2. So there's no critical points in that spot. Let's change to blue, and let's take a look at the second part of this. We'll set that equal to 0. So we have a negative 1/2 plus 1/2 of sine of x over 2. Setting it equal to 0. Moving that negative 1/2 to the other side by adding a half. We're going to do the same process and multiply by 2 over 1. 2 over 1. You get cancellation there. Same thing on the right. You get that the sine of x over 2 is equal to 1. So be careful right here, because you might think, well, I know that the sine of pi over 2 does equal 1, right? Well, that's true. So if you know that and you answer the question, well, when does sine equal pi over 2, right? So when x equals pi, it makes it true. But what about when x is, say, 3 pi over 2? 3 pi over 2, it's not a positive one. Sine of 3 pi over 2 equals a negative 1, right? Just think about the unit circle. Pi over 2, pi, 3 pi over 2, and 2 pi. So if I happen to be right down here, and I'm talking about sine, it's going to be negative. So what's the next loop around? We have, I need it to equal, that's 3 pi over 2. If I go back here, I would be at 4 pi over 2, or 2 pi. And up here, I would have to be, what, 5 pi over 2? Since you already had a 2 in the denominator here, is 5 pi in our domain in this problem? And the answer is no, it's not. So the only critical points are when x equals pi and x equals 0. And it doesn't ask us anything about finding if it's a max or min or anything like that, but it certainly could have, I guess. So those are the only critical points. So good luck with this problem. I hope it makes a little bit of sense, and just having a basic knowledge of what does sine and cosine look like on the graph, and the basic understanding of the unit circle will help you get out of this problem pretty easily, I hope. Alright, good luck with the rest of this.